We're now going to take the sum and difference identities and some techniques that we will need to solve equations using these identities to do some of our equations. Now, it's not going to be any different than what we did previously with replacements. Look at your sum and difference identities on your identity sheet. Identify the one that has the double cosine and the double sign. That's going to be a cosine identity, and if there's a plus in between, it's going to be cosine of a difference. So I'm going to do 4x minus 3x. And most of the time, it's a matter of condensing it down. Then we're going to get cosine of x is equal to negative 1/5. Now, at this point, it's the same as what we've done previously. I would say since we're solving 0 to 360, get a reference angle by doing cosine inverse of 1/5. Just going to make things a little easier. And then your x is going to be, the quadrants where cosine is negative will be quadrant 2 and quadrant 3. So we're going to do 180 minus for quadrant 2 and 180 plus for quadrant 3. So let's get our reference angle, inverse cosine 1/5. And then, like I said, we're going to do 180 minus. Now, I think it's very important to make sure you use the exact answers. So I'm going to grab that answer. In this case, I don't think it's going to be as much of an issue, but especially when you use quadratic formula and you have this ability to go back and grab your previous answers, you do need to go and use that original answer from the calculator, because the rounding that you have on your paper should match up with the rounding that I have on answer keys for worksheets and also for quizzes and tests. You will lose points if you don't have the exact answers and your rounding is different later. So we have our two answers and our angle there, so I'm going to put that in. We had reference angle, 78.463. And then our two answers of 101.537 and 258.463. All right, and our next question is already going to be condensed down, and we're going to look at another thing that happens when we have these sum and difference identities and a technique to work with that. All right, so we're down to the point where it says sine of 2x is equal to negative 1/2. We're going to solve this as if this just says sine theta equals negative 1/2. And really our theta is going to be the 2x. So rather than initially solving for x, we're going to solve for 2x. I'm going to do the same techniques that I just did to start with. Reference angle is equal to sine inverse of positive 1/2, which in this case would be 30 degrees. I don't really need the calculator for this because it's an exact answer. And then instead of writing x equals, I'm going to write 2x equals. Sine is negative in quadrants 3 and 4. So the angles that go with 30 in those quadrants are 210 and 330. Now we haven't fully solved for x, so we're going to divide everything out by 2. We're going to get x is 105 and 165. Now we are solving over the interval 0 to 360, so there's a possibility that there are more answers. And at this step, you are going to want to somehow find coterminal angles until we get all of the angles between 0 and 360. So this is a new element that's going to show up in this type of equation. If you're using your original angles, you can add 360 to each of them. If you do that, 210 plus 360 is 570. 330 plus 360 is 690. And then you can divide each of those by 2. Notice the answers when we divide are still in that 0 to 360 range. Now 345 is pretty close. You could test out the next one and see what happens, but it is going to be out of the range. We're going to do another one that's going to have 3x in it. So normally you get one set of answers, right, of 2 answers. Now when we divide it by 2, we have 2 sets of answers. So if you're looking for a way to kind of know when you have all of your answers, If it's a 2x, you're going to have 2 sets. If it's a 3x, you'll have 3 sets. So more adding for for the higher number of coefficient in front. Now, if you want to skip over doing the step where I added the 360 and divided, another option is 360 divided by 2 is 180. So another option here is I could add 180 to 105 and 165, and that would give me my last 2 values here of 285 and 345. So there's a couple different ways to approach this. That number is going to change. That plus 180 would change. If I was doing 3x, it would be plus 120 instead. So if you want to stick with the regular coterminal angles, you would add 360 to your originals and then divide it out later on. So we're just going to do one more question that will involve using a sum or difference identity and then using this technique just to kind of get used to the idea. So my third one, let's switch back to black here, will be sine x cosine 2x plus cosine x sine 2x equals negative root 3 over 2. This identity is a sine identity, and it's sine of a sum. So we're going to do x plus 2x. And so you can see how the sum difference identities kind of lend themselves to getting this situation where we have a coefficient in front of the x, especially if you're adding. But we're going to do it the same way we did before. So our theta is now 3x, but we're still going to do sine inverse, or get our reference angle. Sine inverse of positive root 3 over 2, or just think about what that is. So this would be 60 degrees. And then again, we're doing sine as negative in the third and fourth. So that's going to be 240 and 300. Now, like we said before, if you have 3x, we're going to have 3 sets. So we're going to have to actually add 360 to each of those twice if we're going to use that technique, which would give me 600, 660. So that's my second set. Set 1, set 2, and then set 3 is going to be 960 and 1020. So 3 sets for 3x. Now if I divide all of those angles by 3, all of my answers are still in that 0 to 360 range. So it's your final answers that you want to make sure you are getting values from all the values that you can possibly get from 0 to 360. Now, like I said, I probably will not go beyond a 3x for, say, a test. It's possible on one of the practice ones you might have a 4x, so you'd have a 4th set of numbers that you would then divide. Now, again, if you didn't want to do that, if you wanted to just get your first 2, here I was adding 360, and then you just wanted to add to the 80 and the 100. 360 divided by 3 is 120. So you could add 120 to 180. That would get you 200. Add 120 to 100. That would get you 220. And then add a second time to get your third set. So just a different option and way of doing it. Obviously, when you do practice in class, you can test out those different ways and ask questions about how to do them. Okay, and there's one more type of question that I think will show up in the practice, so we'll be able to address kind of changing over an equation to make it look like a sum difference identity if it doesn't initially look that way.